Hello, my name is Derek Hardy. I'm with Arrowhead Forensics. I'm here today with Michael Lamper, and we are starting the educational series on the FSIS II systems. Today, the main purpose is to talk about the FSIS systems and why we would use such a piece of equipment on the crime scene or in a laboratory. So right now I want to introduce you to the systems, and then we are going to take a deeper dive into our flagship, the FSIS II Color Lab. We'll start with that. The FSIS II Color Lab is a system that is designed for the laboratory. It comes with a nice 5K monitor, camera, lights, everything you need to find all the latent fingerprints and other types of evidence you would want. And then we have a system that we like to call our hybrid system. It's the FSIS II Rugged Master. This system is designed to not only be able to be used in a laboratory, but it's designed to be able to be deployed to your crime scene. So you're now able to take the system to your evidence. And finally, the FSIS II CSE, Crime Scene Examiner. This system is our tablet-based FSIS system and is designed to be used on a crime scene only by crime scene detectives.
Hi, my name is Mike Lamper. I'm with Arrowhead Forensics, and today I'd like to discuss with you the FSIS II lab system. Before we get started, I'd like to talk to you a little bit about safety. Arrowhead Forensics provides your eye protection when using an ALS system. We also recommend that you use sleeves or a lab coat to protect your skin. Okay, now that we've talked about the safety issues, let's talk about what comes with your FSIS II Color Lab system. First, we're going to go back to safety. It comes with your shield, your clear shield, comes with a set of clear glasses, and comes with a set of orange glasses. Okay, let's talk about your hardware that's included with the FSIS II Color Lab system. First, we're going to start with the camera. It's a 20 megapixel, both black and white digital camera. You have a 50mm lens, and you have a 3-selector filter slider that attaches to the end of your lens. The filter slider is easily turned on and turned off. Next, we have our articulating arm, which is this piece right here. The articulating arm allows you to bring your camera at 180 degrees from where you're working on your surface and bring it down so that you can put it and you can see what you're dealing with and what you're working with. With the articulating arm, you have a 6-inch extension, which is this portion here, and then you have the mounting plate, which is this portion here. Take into consideration that when you're using the FSIS system, that anything that is this height distance to your subject, okay, which is about 19¼ 19½ inches, is going to be 1,000 DPI or better. 1,000 DPI or better is important because if you want to enter these images into AFIS for identification, you will be able to do that from this height here. As you come closer to your item, you're going to bring your DPI up further, so you're going to be in the neighborhood of about 45 to 4,800 DPI in this range right here. All AFIS quality image, if it's not 1,000 DPI or better, AFIS will not accept the image. The camera is attached to the computer with 2 cables. The one on the top is going to be your black and white cable. The one on the back, which is a plug-in cable, is going to be your color cable. All right, also with the system, you have extensions. These extensions are basically used to bring the place between your lens and your housing of your camera and allow you to get that close-up picture. If you're interested in counting pores, this is something that you want to use. Next, we're going to talk about the filters that come with the system. We'll take this off real quick. Okay, the system comes with filters for your ALS lights. The 3-filter slider that's included with the system comes with 3 filters in it. You're going to have your 254 nanometer filter on this side, you're going to have your 550 orange filter in the middle, and you're going to have your 830 IR filter on this side. It allows you to switch easily between the filters depending on what ALS light source you're using. These 2 filters, your 550 and your 830, can be easily interchanged so that you can use any filter basically to look at items under the ALS frequency that you'd like to look under. Okay, now that we've talked about the filters that come in the 3-filter slider, let's talk about the other filters that are included with the system. First of all, you're going to have a 365 long wave UV filter. You're going to have a 455 blue filter, and you're also going to have a 695 IR filter. Okay, now that we're done talking about the filters, let's talk about the light sources that are included in your system. The first light source we're going to talk about is your UV 254 light source. This light source, I would say that you're going to use the majority of the time when you're using the FSIS system because it can see latent images pre-processing and post-processing. Next, we're going to go with the 365 UV long wave. We're going to go with the 455 blue, 525 green, 625 red, and 850 IR to complement the filters that you have with your system. Okay, let's talk about the computer that comes with your system. It's a 27-inch iMac Apple computer with 5K resolution. It's running a Windows platform. Also included with the system is a wireless keyboard and a wireless mouse. The last component I want to tell you about is the foot pedal that comes with your system also. Basically, with the foot pedal, it allows your hands to be free so that if you need to manipulate your light or your evidence, you can still capture that image.
Let's talk about the software that comes with the system. The software that was developed for the FSIS system is meant for this particular camera. And what I want to do is I will open up the program so you can see your workspace. You're going to have a very nice area here where all of your images are going to be seen. You're also going to have a control area or control center on the right-hand side, and you're going to have a quick preferences menu on the top. Now, to get all of this, what I want to show you on the top left-hand corner is your setup menu. So you're going to click on that, and then you're going to come down to preferences. And this is where you're going to pick your save folder, your file type, you're going to name your folder, and then there's certain other aspects of the system that you can control in this menu. So let's go through these. So the save folder, this is a Windows system, so you would create a folder that you wanted to save your images in, and then you would simply point the program to that folder. So every image that you take in this session is going to go into that folder. Image file type, okay? Our images are raw images, however they're called TIFs, .tif, but they are raw. And then the bit depth. You have a choice in this particular system, in the color system, the lab system rather, you have a choice between 8-bit and 16-bit. I recommend staying at 8-bit. It's easier to upload into APHIS. A 16-bit will give you an image twice the size, which sometimes can cause a problem with upload. Now, if you go further down, you'll see this is the area where you can name your image. And it defaults to FSIS underscore. I recommend that you keep that. So you could do something like FSIS underscore knife. And that allows you to realize, now you know that that was an FSIS image that you just took. So something like FSIS underscore, and then you've got a number that can be assigned to it. And this is auto-incremented. So you could be FSIS underscore knife underscore 1. And then your next image would be FSIS underscore knife underscore 2, and on up. The next area that we're going to look at, if we just go straight down, is your Show Save dialog box. I have it checked here, and the reason it's checked is when you click on Save, that Windows Save dialog box will come up, and you can double check where everything is going. So it's kind of a security blanket type of thing. If you don't want that, just uncheck it. So the next one down is Show Image Preview after saving. This is new with the FSIS II. So what happens when you save the image, a preview will pop up and you'll be able to zoom in, you'll be able to move around on your image. You're going to be checking for the correct exposure and maybe your focus. If you like what you see, then you can click it, you can just exit out of that and go on to your next image. Your vertically flip and horizontally flip are below that, and those are used if you're doing things like photographing latents on a clear surface, tapes, bags, whatever, and you may need to horizontally flip or vertically flip it. So if you need to do that, you certainly can do that with this system just by clicking on that and then taking the picture. And then this slightly darker rectangle, darker gray, that controls your color mode. So when you are shooting in color, there are two things that are pretty important here. First is enable color capture module. That should be checked. And two, the enable fast scan color saving. That should also be checked. And the third thing in this section, you'll see that there is a number and then a COM port number, and those two should match. So in this particular case, the number is 6 and the color cord is connected to the COM number 6. It's important that those two numbers match. If they don't match, you simply just need to restart the computer. And then last but not least is this Show Quick Preferences menu. This is one of my favorites. So I have it checked here, so when I click on Save, my Quick Preferences menu pops up, and I kind of tuck it over here on the right, and this is going to allow me to change the prefix name, it's going to allow me to change the increment number, and the save folder. And it's going to allow me to do this in real time, so I don't have to keep opening up or going to the setup and then the preference menu. It's a nice time saver, and it's used quite a bit. So let's go into the control center a little bit more. So within this entire system, there are only 5 things that you can control. Okay, 2 of them are on the camera. The first one is focus. The second one is f-stop, or depth of field. The other 3 are actually in the software on the control center. So let's take a look. So the first one you've got is exposure. Now exposure is going to be just like your shutter speed on a camera, although it's a little bit of a different scale. So what we're looking for here, or what we will see, is that the more exposure you add, the brighter your picture will be. If you want your picture or image to be dimmer, you would just bring that exposure down. And of course, this is all going to be in real time, so you'll be able to see it. The second one is gain. That's the second column, the one in the middle. The gain is like your digital ISO on your camera. So really what you're trying to do is control the noise in your image. This scale is also a little different than you would see on a normal camera. The most important thing to remember here is the sweet spot is 22.5, 22.5. So I've already set mine at 22.5, which is almost to the top of the scale. Remember, it's the sweet spot. You don't have to touch it. This third and final thing that we can control is your gamma, and that is a contrast control, very important for latent examiners. So if you needed to, you could increase your gamma, which will increase your contrast. Or if you wanted to make your image a little grayer or flatter, you could bring it down. The sweet spot for this particular setting is 1.0. Leave it there. That's another one you don't have to touch. So of the 5 things that you can adjust on this system, we've taken care of 2 of them for you. So now you're just down to 3. Focus, f-stop, and exposure. You'll notice at the bottom of the exposure column, there is a times 30 box. The original amount of time that you have is 1 second. If you need more, up to 30 seconds, you can click on this box and it will allow you to have up to 30 seconds of exposure. So below the 3 columns, you're going to see an area that says Use UV Exposure Values. This is used when the pulsating 254 light gets out of sync with the camera. It allows us to resync everything. It's a lot easier to show you with an image on there, so we will be coming back to this. Let's talk about camera modes. So there are 3 camera modes listed and also an additional HDR mode. So full resolution is the first one. Full resolution is your 20 megapixel 1000 dpi or greater image. This is the setting that you will be using when you are actually capturing your image. You'll see that the save button is active when you are in full resolution. Fast scan, which is just below the full resolution, fast scan is a 2 megapixel image and is used for exactly what it says, scanning. So you would have your piece of evidence, you can move your evidence under your camera, or you can move your camera over your evidence, and you're able to very quickly see any rich detail that you may want to capture. When we are in fast scan, you will notice that the save button is now grayed out. This is to ensure that you do not save an image that will not be able to be put up into AFIS. The third camera mode listed down here is HDR scan. And when you click on the HDR scan, you see another menu will pop up. And HDR scan is designed to be used when you have something, your piece of evidence is very difficult to image, whether it be very dark or very wrinkled, lots of hot spots, whatever it might be. You are going to be using the HDR scan to simply look for things very, very quickly. The image is going to be very pixelated, but you're going to see your ridge detail, and from there, you can just move straight up into fast scan, full resolution, and then you'll be able to image your evidence. The button over here to the right of fast scan is HDR. Let's talk about HDR. The premise of HDR is taking the low lights, the highlights, and everything in between on your image, and basically smashing it down on top of each other so you get a very, very nice exposed image. Now, the reason we do that is because the light source that comes with the system, this is a 6 watt, 254 nanometer light source. However, when activated, it is only 1/30th of a watt of 254 nanometers. Therefore, it's not a lot of light. So what we're trying to do is take a small amount of light and spread it out over top of your evidence. So instead of having to take maybe 3 or 4 images of a particular piece of evidence, we can now spread that light across so you're taking one image of maybe 3 or 4 areas of ridge detail. Now, the HDR, when you are activating it, you see that down here under the HDR menu that'll pop up, you will also have another slider. And this slider works very much like the exposure slider, except for it's horizontal. So everything to the right would be a positive number and your image would get brighter. Everything to the left is going to be a negative number and your image would get dimmer at that point. But the point is it gives you complete control of exactly what you want to do. So, it's always better to have something kind of in the middle there. That way you're not getting too much light or not enough light. But the HDR is a very, very good tool to be using. You'll also see that there is an auto intensity checkbox and an enable HDR checkbox. Make sure the enable HDR checkbox is checked. And then the auto intensity checkbox, you can kind of take that off. I recommend that you do, because the premise of HDR is it's going to fight you. You want it to be brighter, but it says you want it to be right in the middle. So there are times in forensic photography where you actually want it to be overexposed or you want it to be underexposed. So this will enable you, if you uncheck the auto intensity, it gives you complete control of this particular function. When it is time to turn off the HDR, you simply are going to click the button at the bottom of this menu, and now your HDR system is turned off. So let's finish up with a few more functions on the camera control. The zoom, it is a digital zoom, so you can zoom closer to your evidence by 25%, 50, 100, or 200%. Now remember, this is a digital zoom. You are not actually moving your camera closer to your evidence or your evidence closer to your camera. So when you zoom in, it is a digital zoom. If you decide to image while you're at 100% zoomed, remember, you are still imaging that entire image. Your other buttons down here are the Save button. And remember, when you are in fast scan, the Save button will be grayed out, so you cannot capture an image in fast scan. Full resolution, it becomes active again. The button over to the right of the Save is Save Color. This will be the color function. When you click on the Save Color, you will have a new menu up, and then you can go into the color function of it. Very easy to do. It's going to give you a begin capture and an exit button. So when we get to the color portion, we'll explain that more fully. So I'm going to exit out of that. Pause live is very important. If you have an image up here and you have a colleague that you would like to have them take a look at your image, you can hit pause live, and then you don't have to hold the light source anymore. It stays up there, it pauses, and then your colleague can come over and you can discuss what you have, and then you'll just unpause it and continue on with your imaging. The Start Integration button. It is located to the right of the Pause Live button. This is our patented process that we use for imaging pieces of evidence that are difficult to image, whether it be a curved surface like a doorknob or a soda can, or whether it be a mirror that's highly reflective with a lot of specular highlights. We're able to actually paint that evidence with light, allowing us to get a very high contrast and sharp image. Additionally, on your curved surfaces like Coke cans, syringes, cartridge casings, it's actually going to flatten that surface, so you'll be able to have the maximum effect of that ridge detail. Directly below the Start integration is a Reset integration button. That would be when you are done integrating your first image, you would hit the Reset integration, and then you can go on and integrate your second image or go to a regular image. It does not matter. And then last but not least, to the left of that is our Exit button. This will exit the program when you are done using it.
Okay, so now we're going to try to find some images with our system. First of all, what you want to do is you want to make sure that your f-stop is at 3.5 or 4, one or the other. You usually start out at 4. Second thing I want to do is make sure that my computer is in the fast scan mode. And the third thing I want to check for is to make sure that my exposure is at 0.30. Okay, now those settings are set. I'm going to take a piece of evidence, which I have here, which is a porous carbon receipt, and I'm going to place it underneath my camera, and then I'm going to put my face shield down, and I'm going to expose it to UV 254 light. And in doing so, I can quickly look across my evidence to see if I can find any images. On this porous piece of paper, there are a lot of images that I see, and there's a really good fingerprint right here. Okay, there's actually 2 together right there. But the other thing that's important with using the UV 254, it's very contingent upon your height of your light and your angle of your light. So if I'm getting this image here, basically if I bring the light over to the other side of my image, I may be able to get a little bit better picture. So it's always good to kind of work your light around your item to see what you can see and where you're going to get your best image. All right, so I found my image that I want to collect. So basically I want to make sure that my focus is nice and crisp in fast scan. I'm still in fast scan. I want to make sure that my f-stop is where I want it to be. And then all I'm going to do is I'm going to jump up into full resolution. And if you'll notice on the screen, the full resolution has maxed out without the times 30 button. So if I click the times 30 button, it's going to allow me to add more light into my object. And if I go up just a little bit on my object, on my scale, you can see that it's going to be very sensitive because now I'm in a 20 megapixel image. Come back down just a little bit. I kind of like what I see there. And then all I'm going to do is hit the save button. And there's my preview. Okay, now what we're going to look at is we're going to look at a shiny surface, but I've exposed this into a super glue chamber for about a minute and a half to add a little bit of detail in reference to the images that I see. If you expose it to the UV 254, you can see that if you add a little bit of super glue to what you're dealing with, and again, this is a CD, a shiny surface, if you add a little bit of super glue to what you're looking at, it really pops. Again, I'm going to make sure my focus is nice and crisp and clear. Okay, I'd add my scale. I'm going to jump up into full resolution. Again, I've maxed out. Let me see what it looks like. Yep, it's too dark, so I want to go to the times 30 exposure. Add a little bit of light to it. A little bit more, see what we get. And I like that. I'm going to hit save. Save. I can take my light away. And this is the image that's collected. Okay, so far I've taken the images and I've been able to use my right hand to get to the mouse and get to the save button on my software program. In cases where you can't, I'll bring up these 2 images. Again, I'm going to really stress on that, making sure that your focus is nice and tight, your light's right, you're still in fast scan. I'm going to jump up into full resolution. When I jump up into full resolution, I've maxed out my exposure bar. I want to add some more exposure, so I'm going to go to times 30. But I want to hold my light with 2 hands. So now I can hold my light with 2 hands, and in doing so, all I have to do is basically move my right foot to the foot pedal hit the foot pedal, and it's going to save that image for me. I can take my light away at this point in time, hit save, and these are the two images that I just collected. Same images, but I used the foot pedal to actually accomplish saving the image.
Now we're going to start with some integration. Integration is by far the feature that you will start using probably about 60% of the time. Your results are going to be phenomenal. Your prints are going to be very sharp and very contrasty. And it's a situation where you will be able to paint your evidence. So if it's curved, if it's flat, as long as it's shiny, you're going to be able to do this. So the example I have for you here is a Coke can. It's cylindrical. It's very difficult to photograph under normal circumstances. So what I'm going to do is I'm going to go right to my starting numbers. I've got my f4, I've got my 30th of a second, I've got my 22.5, and I've got my 1 on my gamma. What I'm going to do now is I'm going to add my 254 light source, and you can see right away that I have specular reflection, and that's going to be a problem. I've got some beautiful ridge detail there, but it's being ruined by this specular reflection. So what I need to do is get my focus in order so I can look just above that reflection and see those ridges, and then I'll just get my focus in order to the best I can right now. I like what I'm seeing there. Now I'm going to add some depth of field. And I'm going to go all the way to an 11 on this one. And what you see is now the reflection of the lights have become thinner. This is actually what I would call our paint brushes. So that's our specular reflection. Now we need to expose for that. So I'm going to bring my exposure down to the point where I see my ridges inside of my specular reflection. And once I get to that point, what I'm going to do is flip it up to full resolution, now at my 1000 dpi or greater image, and I'm going to put my light down for just a second, and I'm going to hit the Start Integration button. And once I do that, now the system is integrating. So I'll bring my light over, and I'm going to pretend like there's an umbrella over my evidence, and I'm going to trace that umbrella over top of my evidence with my light source. And I'm just going to move it nice and slow, nice and even. And as I do, the painting of the pixels, if you will, takes place. Now, what's happening is that as my light gets closer to my lens on top of my evidence, it'll stop collecting, obviously. So what I will do is go to the back when that happens, like right now. Now I'm going to go to the back, and I'm going to do the same thing on the back, and I'm going to paint my evidence. Now, an interesting fact is that there's going to be a stripe right up the middle of my evidence, because there will be a spot where the light, again, is in front of the lens. That's why I have given my can just a little bit of an angle. And then what I can do is just walk my light right up this little bit of an angle, and that paints the middle of my image. And as I'm doing this, you see beautiful latent fingerprints there. Now, I've got that little area in the bottom right that's not quite exposed yet. So what I'll do is I'll just come over here and I'll expose it. And the picture is never going to overexpose because of our proprietary software. So I can take as much time as I want, and I can either clean this image up or maybe expose a little bit over here, expose a little bit over there. If I have like a line that I want to clean up, I can certainly do that. It's not a problem. And then from there, I'll get my finished product. I'll put my light down. I'll hit pause integration. And then what I can do is I can go in here, and you can hit your zoom, and you can see precisely how detailed your latent images are on this can with integration. So now let's look at a piece of evidence that may be a little more difficult to image. We are still going to use integration, but what we have is a box here that actually is what I call semi-porous. So it's cardboard, but it's got a little bit of a shiny sheen to it. So we know there's latent fingerprints on there, but when you try to do an untreated latent fingerprint, look for an untreated latent fingerprint with just regular light, then what you get is a bunch of reflections. This is a perfect example, actually, of what we spoke about with the use UV exposure value. The pulsating of this light is now out of sync with the camera. So this is how we're going to fix it. So I'm holding the light there, and what I want to do is I want to come down here to where it says use UV exposure value. I want to check that. My exposure column will turn black. All I need to do is click one click above the yellow slider, and now it has synced the image. So now I no longer have that wavy image. Now that we've synced the camera, let's get back to integrating this piece of evidence. So what we're going to look for now is I've got my evidence set up under my camera. I'm at an f4. I'm at 22.5, or a third of a second rather, 22.5 on my gain and 1 on my gamma. I'm going to add my light source and see what we see. And this is regular photography when you're dealing with this type of image. Now, if you didn't look closely, you might think that there's nothing really on this. You know, you're trying different angles, you're not really seeing a lot. There's a little bit of ridge detail there, maybe a little on the top, and maybe just something over here you might be able to capture. What I want to do now is, I know there's something there, let's try and get it. So I'm going to add some depth of field. That'll be my first thing to do. So I'm going to go all the way to a 16 on this. And right away, I see that there's a nice fingerprint there. You've got ridge detail over here. You've got ridge up there. And I think there was some ridge at the top there somewhere. So let's focus on capturing what we can see. So I'm going to hit my full resolution. Okay. Maybe just a little bit higher than that, a little bit brighter than that, and then I'm going to start my integration. And now I'm just going to paint my evidence. And much like the can, much like the shiny surfaces, you're getting the same results. And these are untreated on a shinier piece of cardboard. I can put my light down, I can pause it, and then from here we can take a look and see what we got. Not too bad for an untreated piece of untreated print on a piece of cardboard. The last portion of shortwave UV that we're going to talk about today is high dynamic range photography, or HDR. So we've incorporated it into the FSIS II, and I'm going to show you how it works. And remember what I told you before, we're going to take a 40th of a watt of light and spread it out over an entire piece of evidence. So instead of having to take 2 or 3 images of one piece of evidence, we could take one image of multiple latent fingerprints. So what I want to do first is go ahead and set myself up like I normally have an f4. I'm at a third of a second, 22.5 and 1. I'm in fast scan, and I am going to light up my evidence. And right away, you see what I'm talking about. There's not enough light to actually go all the way across the screen. And if I try to do that, then I end up overexposing everything else. So what I really want to do is expose again for those hot spots. So I can bring my exposure down to where I really think it's too low. However, it's going to work out just fine. And then what I'm going to do is I'm going to go ahead and go to full resolution. And when I go to full resolution, it's still going to be underexposed, but when I hit the HDR button, what will happen is it'll spread that light out. And then from here, I can even do something better. Now I have the ability to move it down here. I'm going to uncheck this auto intensity, and I'm going to move it to give me just a little bit more light. So instead of having to photograph just this area, and then just this area, and then this area here with 3 different photographs, now I can do it with 1. And I can even move my light around just a little bit to make sure that they're all lit up appropriately. And when they are, I can either click the save button, or I can go ahead and kick the kick pedal to save my image. So that concludes our integration and HDR portion of the training. Now remember, when you're working in integration, you must be using the 254 nanometer light source. However, when you are using HDR, you can use any wavelength that you want.
Okay, now we're going to talk about color imaging. Basically what I have on the table right now is a fluorescent image that's been processed with a little bit of fluorescent powder. I've switched the FSIS system to use the orange filter that's included. I'm going to use orange goggles, and then we're going to see how we can take a color image with the system if you're using any type of your chemical luminescence, BY40, R6G, any of those chemicals that you may be using to get your latent images to appear. Okay, so now that we've got our glasses on, let's start looking for our image. Remember, our settings on our FSIS system are always going to be the same. We're going to start out at a f4, 1.0 on your exposure, 22.5 on your gain, and 1 on your gamma. Okay, so I know that these lights, these ALS lights, are a lot brighter than what our UV 254 or 364 lights are. So basically, the first thing that I'm going to do is I'm going to change the f-stop, and I'm going to take it down to about an f11, okay? And once I do that, then I'm going to expose what I'm looking at with my light, and basically you can see that it's pretty hot. I may even be able to go down to f16 here, okay? But all in all, not too bad, okay? I like what I see there. So basically, again, we're going to go through the same procedure that we go through with UV 254, is basically we want to make sure that our focus is where we want it to be, okay, as crisp as we can get it by our eye, okay. Then we're going to jump into full resolution. Jump into full resolution and see what my image looks like, and I'm liking what I see there. I'm just moving the light around just a little bit to maybe give it a little bit more light in there. And then I'm going to hit Save Color. When I hit Save Color, it gives me a second or two, okay, because it asks me, it says, please remove external filters. I don't want to do that because I want to use the filter to collect this image. Adjust my exposure and refocus my image. So I'm going to go in, and again, I'm going to have to use ×30 here. And I'm going to adjust my exposure so that it's a little bit brighter. Maybe just a little bit too much. Maybe down just a little bit. Nope. Let's go back up just a little bit. Okay, make sure my focus is still good. And basically all I'm going to do is hit Begin Capture. When I do, it's going to capture that color image. I got to keep my light on the image because it's collecting all of that light that's available to it to give me a nice crisp image. And then once I do that, I can take my light away. And once the light is away, this is the color image that I had just taken right here. I can preview full screen. There's my color image full screen. Very good detail there. Not a lot of your specular reflection going on. This one is actually pretty spot on. This one's maybe a little hot. But like I said, you can still see good detail in there. And then once I do that, I can exit my preview, and then I can hit Save. Save it. Exit together. And then basically to bring up another screen to look at that image again, I could just go into my file where I put it, double click on it, and it'll bring it up in your Windows viewer. Okay, that concludes the color portion of the FSIS system. Basically, with this example, we used the 455 light and the orange filter. Just remember that if you're using other chemical luminescence products, that you want to use the appropriate filter and the appropriate ALS light. It'll work exactly the same as demonstrated with what we have here, and you'll end up with perfect fluorescent images.
So now we're going to enter into the last phase of this, and we're going to talk about IR lights. So the system itself comes with an IR light source, and it comes with 2 IR filters. So when you are looking to use IR to either look for gunshot residue or blood stains or even latent fingerprints, the first thing you're going to want to do is take out your orange filter. Now remember, on the right-hand side, you've already got an 830 nanometer light or an 830 nanometer filter in. So what we're going to do is take out the orange filter, and we are going to put in that second IR filter. So I'll put that to the side, and this is our 695 IR. And I'm going to go ahead and put that into the middle slot of our slide. The reason I'm doing this is because you can gain a little bit of an advantage. Depending on what filter you use, you might drop the background, you might not drop the background, but sometimes you don't know until you try. So when you're using the IR system, what you can do is look at it through one filter and then simply slide it over to the second, and now you're looking at it through the second one. You may get a better image, you may not, but it's a good and efficient way to work it. So what I'm going to do is, because IR, even though we cannot see an IR light source at all, it's very, very bright. So we are probably going to be working in full resolution right off the bat. And I'm probably going to be working at an f-stop of somewhere near an 11 or maybe an 8 to start off with. So what I'm going to show you right now is a bullet hole, a black t-shirt that has been shot. And what we're going to look for is GSR. So I'm going to go ahead and I'm going to turn on my IR light source, and right away you can see that it is reacting. So now I'm looking through my 830 filter, and you can see right off the bat, you can see all the unburnt pieces of gunpowder that were deposited into the shirt upon being shot. But if you move your light around, you can also see the deposits of unburnt gunpowder, and it's giving you kind of a nice little ring there that you can actually measure and use that to help determination muzzle to victim or muzzle to target distance. But let's take a look at the 695 filter and see if it's any different. And if you go to the 695 filter, it's a little bit too bright of a filter, and you lose a little bit of the ability to see that gunpowder. However, you can still see the unburnt. But in this case, I would definitely go with the 830. It's going to give you the best results as far as finding that that fine gunpowder that was left on the shirt and the unburnt pieces of gunpowder itself. So that's an example of using IR if you are looking for your gunshot residue. Now we're going to move on now and look at something that probably isn't used a lot in latent fingerprints. And that is something that's a little bit difficult. We've already seen this. We used this before on our untreated stuff. But what we've done with this piece of evidence, even though the background is really, really busy, we put just a little bit of black powder, because the premise of IR is it's either going to reflect or it's going to absorb, and the powder is going to cause it to absorb, whereas we're hoping the background is going to reflect and we won't see it. So what I'm going to do is I'm going to put this card underneath of the camera, and I'm going to add my light source. I'm probably going to have to refocus, and there we go. And what you see right away is a lot of this background has disappeared, much like the untreated. However, when you look down over here, you've got really, really nice latent fingerprints that have been treated with the powder. So this becomes important if you receive evidence into your laboratory or into your section that has already been processed but possibly not collected yet or imaged. Now you can use IR if there's latent fingerprint powder already on it. Use the IR to gather the image without the background. It's as simple as picking the correct light source, the correct filter, and exposing your camera. So for us, if we wanted to check into the 695 and see that 695 is going to give you similar, very, very similar results. I kind of like the 830 a little bit better. It seems to be a little bit crisper in my opinion, but I've tried them both. I like the 830. From here, I'm already in full resolution. I can hit save, and I have saved my image. So that's IR photography. It's as simple as picking the correct filter, the correct light source, exposing your image, and saving it. That concludes the video for today. I want to thank you for watching, and if you have any questions about any of the FSIS systems, please don't hesitate to reach out and contact us. Thank you again.